All right, so we want to consider integration by substitution. Integration by substitution. So integration by substitution is a very powerful technique for solving integrals. Integration by substitution is a method where you substitute a new variable or expression into the original integral. Then you can now simplify it. And we use it when, one, there's a composite function, which is a function inside another function, or a product of a function where one is the derivative of the other. So let's quickly take some examples on integration by substitution. So number one, if I have an integral, okay, of x square root of 1 minus x squared dx, how do I solve this question? How do I solve this question? So first of all, you need to represent what is under the radical sign with a variable. So we say let u equal to 1 minus s squared. The goal is that when you differentiate, you should be able to cancel the term over here. Okay, so that's when we use integration by substitution. So now we differentiate u respect to x. If I differentiate 1, I'll get 0. If I differentiate minus x squared, I'll get minus 2x. So because there's a term of dx here, I need to make dx the subject. And dx and minus 2x are inversely proportional. So minus 2x can come to the position of dx, and dx goes to the position of minus 2x. So if you look at it, it's going to be like integral of x square root of, whenever we see 1 minus x squared, we put u over there. And my dx is now called du over minus 2x. So now you will realize that this x will cancel this x, and we are left with integral of root u du divided by minus 2. We can factor the minus 1 over 2 out. We are left with integral of root u du. Note that this square root of u is the same as u raised to the power half du. So when I integrate u raised to the power half, I'm going to have, because according to integration, recall that we say that it's the power plus 1 divided by the power plus 1. So that when you have x squared, it's going to be x, the power plus 1, so 2 plus 1 over the same 2 plus 1. Okay, which gives you x cubed over 3. So this u raised to the power half is going to be half plus 1 divided by half plus 1. And half plus 1 is 3 on 2 divided by 3 on 2. So if you look at it carefully, we have minus 1 over 2 here. Okay. Minus 1 over 2 over here. And over here is the same as having like 1 over 3 divided by 2. So it's going to give you 2 on 3. So it means that it times 2 on 3, u raised to the power 3 on 2 plus c. And anytime you integrate indefinite integral, you add c, which is the constant of integration. So these two cancel these two. We are left with minus 1 on 3, u 3 on 2 plus c. But we all know that our u is 1 minus x squared 3 on 2 plus c, which according to indices we can still express it as minus 1 over 3 square root of 1 minus s square cube plus c. So this is how we solve integration by substitution. So we have been able to break all of them to one single term, and now we are able to integrate. Let's take another question also on that. Okay. Let's take another question. So if I have integral of x into bracket s square minus 3 raised to the power 4 dx, how do we solve question like this? So first of all, this is like a function of a function. So we say let u equal to x squared minus 3. You differentiate u with respect to x, you're going to have 2x. Since there's a term of dx here, we need to make that dx the subject. So making dx the subject, we're going to have du divided by 2x equal to dx. So now we have integral of x. Wherever we see x squared minus 3, we put u over there. Raise the power 4. Our ds is now called du over 2s, as you can see over here. So now you see that there will be a term that should cancel. Now you are left integral of u raised to the power 4 du. So we can easily integrate this particular function we see here, which is u5 divided by 5, because it's the power plus 1 divided by the power plus 1. So you're going to have u5 divided by 5, then plus your constant of integration. But your u is your s squared minus 3. So you substitute it. I'm going to have s squared minus 3 raised to the power 5 divided by 5 plus c. So this is how we solve integration by substitution. But one thing you need to understand is that we left this 2 over here. So with this 2, it means that we can factor the 2 out here. Sorry, let me bring it out. So you realize that this is going to be, of which 5 times 2 gives you 10. That's C. So you take note of that. Let's take another question. Integral, this is number 3. What's the integral of x? You have x squared plus 1 raised to the power 3 dx. To solve this, we say let u equal to x squared plus 1. So du dx is going to be 2x. So now we have integral of x u cubed, because wherever we see x over here, we put in u over there. And our dx from here, our dx is du on 2x. So we substitute it over here. And as we said, by how means something will cancel. That makes it integration by substitution. And you are left with this. So when we integrate this, but don't forget there's a 2 over here, so you pull it out. So when you integrate u cubed, you're going to have u4 divided by 4. plus your constant of integration. So this is going to give you u4 divided by 2 times 4 is 8 plus c. But your u is x squared plus 1. So wherever you see u, you put your x squared plus 1 raised to the power 4 divided by 8. That's your constant of integration. So this is how we solve integration question on substitution, integration by substitution. All right, let's take another question. Integrate okay, let's try this question. So to integrate this, we need to say let u equal to sine x. And when you differentiate u respect to x, you're going to have, if you differentiate sine, you get cos. So we make the s a subject, which will be du divided by cos s equal to dx. We said that this ds and cos s are inversely proportional. So you can interchange them. So now we're going to have integral of u raised to the power 4 cos x times, wherever we see ds, we're going to put du over cos x. So you realize that cos s will cancel. We are left with u raised to the power 4 du, of which we can integrate now. If I integrate u raised to the power 4, I get u raised to the power 5 divided by 5 plus your constant of integration. But your u is sine x. So you can substitute it over there. You're going to have sine 5x divided by 5 plus c. So basically, this is how we solve questions like this. Okay, I hope it is clear. So it's not anything difficult at all. So make sure you practice more. So I want you to pause the video. I want you to try this for me. Integral of 5x square root of 2x squared plus 7. I want you to try that for me. See you in the next video.